Okay, so last time when we started off, we started talking about differences in proportions, and so we'll move now to differences in averages. Siri thinks I'm talking to her, and I'm not. Please go to sleep, Siri. So when we think about differences in averages, right? So we're looking at how the means differ between groups. And again, this follows the same kind of principles, right, where we estimate a difference, right? So we're focused on estimating the difference. And determining whether, one, that this is, actually not zero, so that there actually is a difference. And, more subjectively, right, is understanding is this noteworthy? So this is something that, you should really like, is it substantively significant, right? So we'll walk through sort of the example I have in the notes as well. So where we talk about the Texas Rangers, having a terrible starting rotation ERA of 6.97. So this means that the starters are, allowing 7 runs per 9 on average, right? That's what that means. Although, fun fact, I did read in the Dallas Morning News this morning that at the time of this recording, the Rangers had the best starting rotation ERA in the American League. Whoa, that's going to tank later, and everyone knows that. But for right now, things are feeling good. But and then the actual worst team, maybe in the major leagues, maybe possibly worse than Houston. It's debatable. Is Anaheim. Zach, they're the Los Angeles Angels of Anaheim. No, that's a stupid name. We're the Los Angeles Angels. Y'all are in Orange County. Like, leave us alone, right? You're Anaheim. You always will be in my heart. So with Anaheim, right, historically, the Angels have been better, and they always whip up on the Rangers, and it's really kind of sad, right? I consider the Anaheim to be the chief rival of the Texas Rangers. Houston may be like down the road, right? But for me, growing up, it was always Anaheim. Why? Because I used to watch the Ken Griffey Jr. or used to play the Ken Griffey Jr. N64 game. And I remember Tim Salmon always raking against the Rangers when I played against them. Funny how the top players from the Angels are both fish, Tim Salmon and Mike Trout. So anyway, the first thing, that we do for assessing differences between here is, we look at this, right? If we did the math on this, so what is the actual difference, right? Again, simple subtraction problem. And we would know that this is 4.03, and this is given from 6.97 minus 2.94. Boom. Now we know that's a difference, and of course, obviously, maybe we could eyeball it and make a decision that way. But we also know that, is this actually that different? Or are they actually different? Because, if we have a small sample size, maybe we don't have enough evidence to make a final determination. If there's a lot of variation, that number could be skewed, and so maybe that's not great either. So the point of this is how we go about determining that, right? So based off this information, right, if we look at all the innings, right, based off that, the samples in of all possible scores, for this particular example, right, we would see that the Texas Rangers, based off of the made-up data that I had for this, right, SD, which is sometimes noted S, we'll just call it S or SD, is 1.15, right? And if we look at the Anaheim, right, we know that Anaheim, their SD is 2.37. All right, so we know this is the difference. These are the standard deviations for both. And if we look at the innings, so this is like the total sample, something like that. Texas would be, 197. And for Anaheim, right, 156 innings. This is probably not something, I mean, so this means that Rangers, they're longer, they're going to get more runs because their bullpen sucks. Anaheim, I don't know. Doesn't really matter, right? So if we translated this into like formula kind of stuff, right, we would see that S1 for the Rangers then, so the standard deviation for them is 1.15. And we would see that N1, so the number of innings, is equal to 197. If we look to Anaheim, we would see that S2, so the standard deviation of the second group, is 2.37, and we would see that the number of innings for this group for them is 156, right? So we have all this information. We know that the mean difference, right? So the X bar difference is 4.03. Man, I mean, my email's blowing up. So from there, then, you know, we have to do the same thing, right? So we calculate this similar to stuff that we've already done. Our next step then is to calculate the standard error, right? And so this should look relatively familiar, seems like, you know, kind of intuitive, right? So this is going to be equal to, so the standard deviation of the first group, in this case the Texas Rangers, divided by the sample size, right? Now we're also going to square it. For those of you who remember or maybe don't remember, right, we're also, the squared standard deviation is known as a variance, right? So we're taking the variance of that group or squaring the standard deviation, right? Both are correct, but it's important to know how these are related, right? So you're like, no one's gonna like dinged for that or anything like that, but just be mindful of that. So then we have here too, is that we take the squared standard deviation or the variance of the second group divided by that sample size, and we are going to take the square root of that, right? And this is going to give us the standard error. So what we have here then is that if we, you know, transform this and put in some numbers, it would look like this, right? So it would be 1.15 divided by 197, and then we would add this to 2.37, and this would be 156. We would do this number. I'll allow you to do the math, right? But what this would ultimately come out to then is 0.0145, 0.168, and this would be 0.15 for the standard error. So we have that handy dandy formula. What does this all mean, right? So now we want to start making some inferences with this new information, right? So we go back to our difference, right? We see that it is 4.03. And if we know that if we're finding like a z-score for this, we take 4.03, we divide it by the standard error. And if I use my handy dandy R program, 4.03 divided by 0.15. This is going to equal 26.87 rounded. So this basic more or less says that, you know, note that we look for like for 95% confidence, right? We look for like a score of 2 or greater. 26 is definitely larger than 2 by, you know, about 13 times. So we'll say that's statistically significant. Another way to look at it, right, is remember again that if we want to create a 95% confidence interval, which I don't know, I personally don't use that in my own work, but you know, whatever. We would do 1.96 because that's the critical value for 95%. You know, if we used 90%, it'd be 1.64. I forget what the one is for 99% confidence interval. I want to say that's like 2.06. Is that right? I don't remember. It doesn't really matter. But here we'd multiply it by the standard error, in this case, 0.15, right? So if we did that, 1.96 times 0.15 be 0.294. So what our answer would be then is that we would take our difference, right? So what we're saying is the difference between the starting rotation ERA for the Texas Rangers and the Anaheim Angels is 4 earned runs per 9 innings, give or take, plus or minus 0.294 runs, right? So if we did 4.03 minus 0.294, so what we're actually saying then is that the range of this then is, it's somewhere between 0.734, or this is a 3.6. No, we're going to erase that. So it's within 3.73 rounded, and 4.03 plus 0.294 is 4.324, right? So somewhere around then and there, right? So based off this information, right, we know that this is a large difference, right? So, big difference show there equals a group difference. That is substantive, right? So it's more than just being statistical, group difference. And since we're talking baseball, this is a huge difference in a marker of quality. Like, Rangers pitching isn't winning any games. Let's just say that, right? But Anaheim baseball, they're winning some games based off of their pitching because they're keeping it close for their hitters to get to it, right? If you're the Rangers, you're giving up 7 runs a game. Like, just why are you even here? Go back to play in Double-A Frisco. Where does Anaheim? Oh, I think Anaheim has a team in San Bernardino. Go back to the if like someone from Anaheim was doing that, you're stuck down with the 66ers, I think that's right, because it's for Route 66 or Route 66. But we make the difference then that, within this range, like it's a huge earned run average per 9 between each team. And we would conclude that because the number is low for earned run average, which is the way this is scaled, that Anaheim has the better starting rotation. So with that, we'll go ahead and end this video.